Welcome back, everyone. In today's lesson, we are going to look at virtual LANs or VLANs. Now, these are the objectives of this lesson. We are going to look at VLAN segmentation, implementation, inter-VLAN routing, and also troubleshooting. Firstly, let's look at an overview of VLAN. Now, VLAN can segment LAN devices without regard for the physical location of the user or the device, hence the name virtual LAN. Now, if you look at this figure over here, you will see that these people in VLAN 2, which are IT people, they are all in different floors of the building, but they are within the same VLAN. They belong to the same subnet. These people in HR, they belong to this subnet, which is VLAN 3. And the people in sales belong to VLAN 4. Every VLAN is a collection of people who are not physically near each other, but they are logically within one subnet. You could say they are virtually in the same LAN, hence virtual LAN. Another thing, every VLAN is its own subnet. So every PC or device within that VLAN must have an IP address that is within that subnet. That is how they can communicate with each other. Now, if, for example, people in VLAN 3 or VLAN 4 wants to communicate to people in VLAN 2, meaning that you want to communicate inter-VLAN, then you would need routing capabilities, and that is where the router comes in. So why do we need routing capabilities? These are different subnets, and different subnets, different LAN, when they want to communicate with each other, they have to have routing capabilities. VLANs are logical connections with other similar devices. VLANs are mutually isolated, and packets can only pass between VLANs via a router. A VLAN is a logical partition of layer 2 network. So device that is always in VLANs or used in VLANs are layer 2 device, which is a switch. Multiple partitions can be created and multiple VLANs can coexist. The partitioning of the layer 2 network takes place inside a layer 2 device, usually a switch. Each VLAN is a broadcast domain that can span multiple physical LAN segments. Hosts on the same VLAN are unaware of the VLAN's existence. If you remember from a previous notes in your netcom class, this switch is actually partitioned into 3 different VLANs. And although all of these devices here on level 3 are connected to the same switch, they cannot communicate with each other unless they are in the same VLAN. Placing devices into various VLANs have the following characteristics. One, it provides segmentation. Okay, various groups of devices on the same switch can be divided into groups that is mutually exclusive, if you will. Provide organization that is more manageable. When, let's say, you want to do access control, so if you partition the switch into different segments or VLANs, then certain group or certain VLAN can do certain things and you can set that. It gives you a better management tool. Broadcast, multicast, and unicast are isolated in individual VLAN. Now, if you remember, when we talked about broadcast before, switches are gossip central. It will send everything to everyone. Connection, if this is not a VLAN, let's look at this here. If this is no VLAN, this one whole building is one big broadcast domain. That is not a good thing. But using VLAN, we have divided the broadcast domain. So if somebody or any device within this VLAN decides to broadcast, it only broadcasts within the VLAN. It doesn't go to the other VLAN. Okay, so it is isolated in the individual VLAN. Each VLAN will have its own unique range of IP addressing, and then we have, of course, a smaller broadcast domain. So what are the benefits of VLAN? I think it is very clear, but let's go through this anyways. Smaller broadcast domains. Dividing the LAN reduces the number of broadcast domains. Improved security, only users in the same VLAN can communicate together. Improved IT efficiency, where VLANs can group devices with similar requirements, for example, a faculty versus students. Reduced cost. One switch can support multiple groups of VLANs. Better performance. Small broadcast domains reduce traffic, improve bandwidth. Simpler management. Similar groups will need similar applications and other network resources. So it gives you an ease in management when you group things together. So when we're talking about VLANs, there are many types of VLANs. Okay, and these types of VLANs are needed within the switch for them to work. So we have the default VLAN. Default is the first thing that happens. It is by default there, and every port within that switch is within that VLAN. Once you make data VLANs, then you have to take these ports out and assign them to the VLANs. Then we have native VLAN, management VLAN to manage, and voice VLAN. Default VLAN is also known as VLAN 1. So VLAN 1 here is the default VLAN. It is the default native VLAN. It is the default management VLAN. And one thing about this default VLAN is that it cannot be deleted or be renamed. It is by default there, and it's like doing everything until you configure otherwise. But it cannot be deleted and it cannot be renamed. So while we cannot delete VLAN 1, Cisco will recommend that we assign these default features to other VLANs, meaning that we create new VLANs, VLAN 10, 20, 55, whatever. Data VLANs are commonly created for specific groups of users or devices. They carry user-generated traffic, and VLAN 1 is the default data VLAN because all the interfaces are assigned to this VLAN. A VLAN carrying voice or management traffic would not be a data VLAN. That will be a voice VLAN, and we will look at that in a little bit. Native VLAN is the VLAN that carries all untagged traffic. Later on, we would see that within VLAN, we have untagged traffic and tagged traffic. Okay, don't worry about that yet. So, native VLAN is used for trunk links only. All frames are tagged on an 802.1q trunk link except for those on the native VLAN. We will see a lot of this protocol, 802.1q, and down the line, it will be known as .1q. The native VLAN is VLAN 1 by default. Of course, then we have to change it to something else because we don't want it to stay as VLAN 1. Management VLAN is a VLAN that is created to manage. It is created to carry network management traffic, including SSH, SNMP, syslog, and more. VLAN 1 is the default VLAN used for network management. This is used for SSH or Telnet virtual terminal traffic and should not be carried with end-user traffic. Voice VLANs are used to support time-sensitive voice traffic. Cisco switches support a voice VLAN that requires a short bandwidth, delays of less than 150 milliseconds across the network to ensure voice quality. Transmission priority over other types of network traffic, meaning that if there is data and there is voice, voice gets higher priority. Ability to be routed around congested areas on the network. The voice VLAN features enable access ports to carry user and IP voice traffic. In this figure, if you look here, you will see that switch S3 port FO18 has been configured to take student traffic on VLAN 20 and voice traffic on VLAN 150. So this one particular port is configured for two different VLANs. One is the student VLAN, which is VLAN 20. This is data VLAN. And we have the VLAN 150 for the voice traffic. That is the end of the VLAN overview. As we go on, we will look at implementation, configuration, and troubleshooting of VLANs. Until then, goodbye.